Hi guys, welcome back for part 2 of the distributive property. In this part, we were going to focus on how to distribute when the number in front of the parentheses is negative, and we'll talk about why you need the distributive property and why you also need PEMDAS, because those are two very different things. Let's start with some examples of distributing a negative number. In this problem, I have a number in front of my parentheses, which I will distribute, and that number is -2. Make sure that you're distributing the sign with the number. In our last video, we talked about making sure that we know how many terms are in the problem so that we don't accidentally over-distribute. Terms are separated by adding and subtracting. So in my parentheses, I have 1, 2, 3 terms. Again, the 6yz, since they're all right next to each other, is considered one term. So I will be distributing -2 times x, -2 times 6yz, and -2 times the -5. When it's just a number and a letter, you're just going to write them right next to each other. So that first one will turn into a -2x. If there was already a number as part of that term, you will need to multiply the -2 and that number together. So -2 times 6 will turn into a -12. If you'd like, you can write that as a -12 or as a plus -12. And then don't forget the yz next to it. For the last one, we have this double negative sign. We have a subtraction problem and a negative number. And just like we learned on our adding and subtracting video, we can change that to a plus and a positive number. And so that last number is going to turn into +10. This is my final answer. Notice that the signs of each term changed when we distributed a negative. It was a positive x, now it's a -2x. It was a plus 6yz, now it's a -12yz. It was -5, now it's +10. That will always happen when you're distributing a negative number. All of the signs will change. Let's do another example. In this example, I've got a couple things outside the parentheses. When you're distributing, you always want to make sure that you are only distributing the number that is touching the parentheses. So in this problem, I'm going to distribute the 5. Now, that subtraction sign in front of the 5, that's attached to the 5. In fact, if we wanted to, we could rewrite this as a -5. And so I'm going to be distributing a -5. If the number is being subtracted, it is a negative. Inside my parentheses, I have 1, 2 terms, so I'm going to be multiplying -5 times the 4y and then -5 times the 7. And just like in our previous problem, all of the signs of the terms inside the parentheses are going to change. So it was a positive 4y, it will now be a -20y. It was a +7, now it will be a -35. So make sure that all of the symbols change. The most common mistake I see on these problems is forgetting to change the second symbol. So really make sure that you're multiplying by a negative and that second symbol changes. Let's do one more example. In this problem, again, I'm going to be distributing. I'm not going to distribute the 8x. It's too far away from the parentheses. But right next to my parentheses, I have a negative sign. And technically, there's an invisible 1 right in front of my parentheses. Everything in the whole entire world is being multiplied by an invisible 1. And so in this problem, I'm going to take this -1 and I'm going to distribute it to the 4y and to the -7. Now, again, just like in the last problem, if you want to, you can change this to plus -1 so that you're just distributing the -1, and you can write a plus sign here if you want. Just make sure the key thing, the thing that most students, if you're going to make a mistake, this is where the mistake is going to be. A lot of students will forget that it's a -1 and that there was already a minus sign here. and that those are going to cancel out and become a positive. That's like the most common mistake. So if you see a problem and there's a negative sign in front of a parentheses, make sure that you're changing all of the signs inside the parentheses. If it was a subtraction problem, for the final answer, it'll be an adding problem. Okay, and that's how you distribute a negative. The final thing I want to leave you with today is I want to show you why we don't do the distributive property when we have only numbers in a problem. Okay, so we talked about this on the first video. If we have a problem with only numbers, we're supposed to do the order of operations, PEMDAS. We're not supposed to distribute. The D in PEMDAS is not for distributing, it's for division. But let me show you why. So here, I'm going to do it first. First, I'm going to do it wrong. I'm going to use the distributive property, and I'm going to get the wrong answer. And maybe you don't want to write this down because this is not correct. Or if you do write it down, put a big X over the top of it. All right, so here's my distributive property. So in my distributive property, I take my 5, and I'm going to distribute it to every number on the inside. So the 6, the 3, and the 4. So 5 times 6, 5 times 3, 5 times 4. Next, I'm going to multiply those numbers together. 5 times 6 is 30. 30 times 5 is 150. 150 times 3 is 450. I'm not going to subtract because I have to do all of my multiplying before I subtract. So 5 times 4 is 20. And I think the answer is 430. That's using the distributive property. Now that's a really, really big number. And so let's check and see, what do I get if I use PEMDAS instead? If I do PEMDAS instead, I'm not going to distribute the 5. If I'm doing PEMDAS instead, I'm going to start by simplifying the inside of the parentheses down to a single number. So I'm going to start with 6 times 3, which is 18. Next, I'm still going to do parentheses because I still don't have that single number on the inside. 18 minus 4 is 14. And I'm down to my last step. I just need to figure out what 5 times 14 is, and it is 70. It is not 430. So much smaller than 430. And this is the correct answer. 70 is correct. Okay, and so look at how different it is. So when you do the distributive property, you run the risk of maybe doing it incorrectly and then getting a number that is way far off from what the actual number is. So make sure that if a problem has only numbers in it, that you're using PEMDAS. The distributive property is only for numbers with variables. That concludes our video for the weekend.